Hey guys, so today we're going to be doing a factoring review. So this is Mrs. Sherman. So you guys did a significant amount of factoring last year. And our next section is pretty factor heavy. So we just want to make sure to remind you of some stuff for you guys to practice a little before we get into the new stuff. So today I'll go through a few examples with you. You will try a few on your own. Make sure when you come back to class, you ask questions if you have them, because then we will be building off of these concepts. So let me just remind you of what we're doing. Hopefully some of this does look familiar, but let's be honest, you probably haven't done it in 6 months. So I feel you if you don't remember. So here's our starting example. I think I'm going to do about 5 or 6 examples with you, just things to remind you of. So if I have something like 6x squared minus 17x minus 45, and I say factor that. So just as a reminder, factoring means to divide. So we want to take this quadratic trinomial and divide it into 2 binomials. To do so, we need to divide up the factors. So we always start with the first term, the quadratic term in this case, and I'm going to find the factors of 6x squared, aka what things could I multiply together to get 6x squared? You can multiply 6x and 1x, or 3x and 2x. So once again, we know the factors of 6 and 1 and 2, or 3 and 2. And x squared, you're just basically splitting up. If I have x squared, that's x times x. So we're going to find the factors of the first term and the last term, the constant term in this case. So the factors of 45 would be 1 and 45, 3 and 15, or 5 and 9. So we have a few options. So one thing is we don't want to be sitting here forever doing this. So we have a few things that can hopefully help us out. You can see I kind of wrote my pairs out in order. I always work backwards off these pairs. I want to work with the pairs that are closest together first. It doesn't work every time, but it works a lot of the time. So it's a good strategy to start with. So I'm going to start, I'm going to start with 3x and 2x, because once again, they're closer together. And then I'm going to start with 5 and 9. As you're plugging your factors in, because you can put them in either parenthesis here, just as a heads up, you cannot put common factors together unless there's a GCF, which we'll talk about in a second. There is not one here. So I could not put a 9 in here because 3 and 9 have a common factor. So I'm going to try the 5 here, the 9 here. And then what you're always doing is basically just checking. We know that 3x times 2x, if I distribute it, is 6x squared. I want to check these two terms, multiply them together. That's going to give me 27x. Multiply these together if I were starting to distribute to get 10x. If I did that last, I know I got 45. What I notice is that's a negative. If you ever have a negative for your constant term, that means your signs are going to be opposite. So you'll have one positive, one negative. So I'm asking myself, is there any way for me to combine this term and this term to make this term? So that's always our main goal. Can we combine those to make the middle term? And the answer would be yes if I had opposite signs, because if I had negative 27 plus 10, that's going to give me negative 17. So my last main thing I have to do is just fill in my signs. That would give me a negative 27. That would give me a positive 10. And now I have my factored form. So there you go, just as a quick little reminder. So let's look at some other ones that will pop up as we're going, so it's good to see and remind ourselves of. So we might see a problem like this, 25x squared minus 144. This is a special case. It's called the difference of two squares. What do we notice is there's a difference, aka subtraction, and these are perfect squares. So when you see difference of two squares, I'll just remind you of the quick little shortcut. Basically, you're going to use square roots to help you out. You're going to take the square root of the first term. So the square root of 25x squared is 5x. You're going to take the square root of the second term. The square root of 144 is 12. So that gives you all your terms. And then for difference of two squares, there's always one positive and one negative. And the reason we always have a plus and a minus is because when you did do your distributing, you would get negative 60, positive 60x, and they would cancel each other out, which is why there is no middle term. Sometimes I'll refer to this as dots, difference of two squares. So if you ever hear me randomly say or write dots, that's what I mean. So those are some cases that pop up quite a bit. So a few more. Okay, so if we started with this one, one thing we do always want to look out for, and it didn't happen in the first two, even though I always check anyways, is you want to always look, is there a greatest common factor? Because if there is, you need to take care of it as your first step. So when I look at this, these are all divisible by 3. So I'm going to divide that 3 out first. I'll get x squared plus 2x minus 15. So one, you have to do it. You might as well do it as your first step because now these numbers are way smaller. So you're going to have less factors, less work. So your first step is always check for a GCF. Now I'm going to go through the factoring steps we just went over. Find the factors of x squared, that's just x times x. Find the factors of 15, either 1 and 15 or 3 and 5. As I'm writing my answer, just don't forget that GCF has to stay there. So I'm going to put that there so I don't forget about it. I'm splitting up my x and x because that's my only option. And then I'm going to start with 3 and 5 and see if that works. So as we're doing it, you're just checking, okay, that's 5x and that's 3x. Can I combine those to make 2x? Once again, they're going to be opposite signs. Yeah, I can if I have a positive 5 and a negative 3. So I'm just going to fill in my positive 5, negative 3, and that would be your final factored form. Just make sure that GCF stays on the outside. So very similar to the first one, but that extra GCF step, always be on the lookout for that. Okay, so a few more, just a few little other things I would like to show you today. So if we start with 6x to the 4th, ooh, how exciting. Throwing in a different variable here. And I say factor this. You would say, okay, I'm going to go through my steps. I always set up my parentheses first. Okay, feeling good about life. I'm going to find my factors of my first term. Now we know that 6 is 6 and 1, but now we have x to the 4th instead of x squared. So when I split up x to the 4th, you want to kind of split it up so your exponents are even between the two. So it would be 6x squared and 1x squared, or 3x squared and 2x squared. Okay. So once again, you're just splitting it up evenly. Your hint is whatever's in the middle should be what your exponent is up there. For 12, what do we got? We got 1 and 12. We got 2 and 6. We got 3 and 4. And we're going to start to fill in and kind of just see what works. I'm going to work backwards once again. So I like to write it in order, but always start with the ones that are closest together. So we have 3x squared and 2x squared. So I'm splitting those up. I'm going to start with 3 and 4. But as a reminder, I can't put 3 here. I'm sorry, because I did check. There is no GCF. I should have said that as the first step. I can't put 3 here. Common factors cannot go together. So I'm going to put 4 here, 3 here. I'm going to see, does this work? I have no clue. So that's 9x squared. That's 8x squared. Hex, yes, that works because with opposite signs, if I have negative 9 plus 8, that gives me negative 1, right? So I'm going to throw in the negative, the positive, and that would be your factored form. Delightful. Okay, just 2 more quick ones. The next one's going to look very similar. So I'm going to say we're going to factor 6x to the 12th minus x to the 6th, y to the 3rd, minus 12y to the 6th. Okay, if you actually notice, these all have the same coefficients, a 6, negative 1, and negative 12. This one just has some extra variables with it, so we just want to make sure we know what to do when we see that. So I find my factors. 6x to the 12th. It's either 6x to the 6th, because I kind of split that in half, times 1x to the 6th, or 3x to the 6th times 2x to the 6th. Over here, this is either, now I have a variable now, so I have to split it up. 1y to the 3rd, I'm splitting it in half, times 12y to the 3rd. 2y to the 3rd times 6y to the 3rd, or 3y to the 3rd times 4y to the 3rd. Okay, so we have a lot of options going on. Our main goal is I'm going to start to fill in my parentheses. You probably have an idea of what my numbers are going to be from the last problem. So I'm going to start with 3x to the 6th, 2x to the 6th. Once again, this has a variable now, and that's okay, but I'm still going to start with 3 and 4. Once again, 3 can't go here, so I'm going to start with 4y to the 3rd, 3y to the 3rd. I check my signs. This, I'm doing the same thing I did up here. This would give me negative 9. This would give me positive 8. So really the steps didn't change. So don't get freaked out if you see more variables happening. You're really just trying to split them up evenly between your binomials. But it's really focusing on the coefficients to figure out your numbers, and then the variables you just split up. All right, one more problemo here. It's going to be 12x to the 6th minus 147x to the 4th. And I'm going to say factor that. So what I noticed, oh, there's only two terms. So the first thing I think is difference of two squares. That pops into my head. But I'm saying, wait a second. To do difference of two squares, I needed perfect squares, which I definitely don't have. So this is always your hint, and this is something you should be doing for every problem anyways. Is there a GCF? And there is. These are both divisible by 3. I'm also noticing that they both have x's, so they have that in common as well. So when I say they have x in common, if they both have it, you take the one with the lower exponent. So they have 3x to the fourth as common factors. Once I divide that out, I'll be left with 4x squared minus 49. Now this is looking better as a difference of two square problem. So I'm going to make my parentheses. I'm going to just make sure I bring that GCF down because it has to be on the outside of my final answer. And now I'm going to just do my quick little taking my square roots. The square root of that first term is 2x. The square root of the second term is 7. And we're going to have one positive and one negative. And that would be your final answer. So hopefully that brings back some good memories of factoring in the past. So feel free to refer to this if you have any questions. We will be doing more obviously in class, so come in with questions as well. You guys are going to be trying a few as your assignment today, so just do your best, and we will go over them in class, or go over whichever ones you like. So feel free to shoot me an email if you're having any difficulties. But other than that, good luck, and I will see you later. Bye.